even suspects that the sense system to measure musical intervals is used on gamelan ensembles more than on any other musical tradition in the world. Now, most researchers that actually go back to the first half of the 20th century and the beginning of the second half have some things in common. A lot of them actually have a speculative character. So they are based on tone measurements, but they actually based on speculation. The second one is they are based entirely actually on the measurements of the fundamental frequency of gamelan ensembles. Now there's one research, which is the starting point of my research, done by the American scientist William Thesaurus. Thesaurus is a professor of electronical engineering from Wisconsin, and he is relating the spectrum of gamelan instruments to the tuning. Now, Thesaurus is relating his research to Helmholtz, who actually defined the term auditory roughness in the 19th century as the kind of buzzing sensation created by two close-by frequencies. Now, Helmholtz defined the perception of roughness as dissonant. So what the Thesaurus is actually doing is plotting a spectrum or calculating actually the combinations of a spectrum together and then plotting the positions of minimal roughness. So we have actually a curve where we can see the points of minimal roughness and the points of maximal roughness. And he is recording, or he recorded different gamelan instruments and analyzed the tuning. In his theory, he is specializing on two instruments we see here. On the right, the bonang, so basically lying gongs, and the saron instruments, which consist out of sound bars. So he is measuring the overtones, or he measured the overtones, picked out certain overtones, and labeled them as a generic spectrum. So a generic bonang spectrum, a generic saron spectrum. He actually plotted the points of minimal roughness. And what he found is that the points of minimal roughness of the bonang spectrum lie close to one of the Javanese tuning systems called slendro. And the minimal points of the generic saron spectrum lie close to the points of minimal roughness of the other tuning system used in Javanese music called palok. So his conclusion is actually that the slendro tuning system can be seen as related to the spectrum of the bonang and the points of minimal roughness, and the palok system can be seen as related to the saron. However, there are some problems about this approach. So we have both instruments actually used in one ensemble. And if we imagine that actually the bonang is a result of the minima of the roughness, and therefore also of the minima of the perceived dissonance, and the saron also, and both instruments are used in one ensemble, we would maybe assume that there is still a kind of roughness. Another thing which is problematic is we have in all of Southeast Asia instruments of similar shape, but actually with different tunings. Now, if the tuning of Javanese music is a result of the points of minimal roughness and therefore minimal dissonance of the bonang spectrum, for instance, other tunings would of course we would assume that other tunings would create roughness and therefore dissonance. So some assumptions that actually lead to the question of my research. We would assume that, if we would assume that the theory of the Thesaurus is correct, we would assume that actually the spectrum of the instruments is a result of the points of minimal perceived dissonance, and therefore other tunings might sound dissonant because they lie not to the minimum points of musical roughness, and the roughness levels are higher. So the idea of my research was to compare different tuned gamelans, gamelans that are tuned traditionally and gamelans that have different tunings. So in order to do that, I want to introduce you first to the methods. Now, we have also in Indonesia actually some gamelans and also in America that are tuned not traditionally. For instance, the composer Lou Harrison from America had a gamelan design that was tuned in just intonation. And we also have some examples from Indonesian fusion music genres where we actually have gamelans also tuned to equal temperament, or a kind of equal temperament. Well, but of course here they are not really accessible. So the basic idea of this research was to record an existing gamelan, take the samples, pitch shift the tones, and then measure the roughness and measure the perception of dissonance. So the basic steps are of my method: recording a gamelan, pitch shifting, sampling, measuring of auditory roughness, and we did a survey. For the recording, we used the gamelan of the Consulat of Inonesia, which is not far from here. The gamelan is called Margi Bodoyo. During the recording, there was only the Palok half, so one tonal system available. So only this tonal system was recorded. The main important instruments were recorded that are necessary to, that are actually necessary for a gamelan composition. Then the tones of the gamelan were sampled. For that, a sequencer software was used, and they were sampled in a way to create a traditional gamelan composition. For that kind of purpose, we used the composition Manya Sewu, which is one of the standards of gamelan repertoire, and is actually a really simple piece that has a really regular melodic pattern and easy to sample. Only the main instruments were used for the sampling. Then afterwards, the instruments were pitch shifted. Different kinds of stimuli were created, and before of that, there was a conception of different tunings used for the survey. The roughness measurements were done with an algorithm designed by Professor Bada, which is based on Helmholtz and the assumption that the maximum roughness level is at a hertz difference of 33 hertz. And the algorithm is actually working by splitting up a complex sound into the spectral components, calculating all the possible combinations, and then the sum of it is actually the roughness level. Later, with the stimuli, we did an online survey with gamelan musicians from different international gamelan groups, and we later related the roughness measurements to the results of the online survey. So first, I want to introduce you to the stimuli that were created. The basic idea was, as I said, to use the original tuning and create different kinds of tuning. First, an kind of equal temperament version of the original Palok tuning was created by just like using intervals of the equal temperate tuning that are close to the Palok tuning and pitch shift the instruments in that way. Then actually, because the Slendro tuning, another traditional Javanese tuning, was not available at time of recording, so is slendro tuning, or the frequencies of a slendro tuning from the literature were used, and to create a slendro tuning out of the original tuning. Slendro is often described as almost equidistant tuning, where the intervals actually have almost the same size. So, which is actually not directly true because the intervals vary a little bit. So actually, we made the intervals more closer to each other to make like a kind of equidistant tuning out of the slendro tuning. Then the Gamelan tunings actually have stretched octaves as pianos also. So it was decided to make a tuning out of the original Pellac tuning that has actually straight octaves. So the octaves were actually straightened. Then there was the idea to make a pentatonic minor and major tuning out of the slendro tuning that was created by lowering and some intervals actually. There's another experimental tuning I called pseudo-hijaz, which is inspired by Middle Eastern tunings actually, and one tuning where I randomly detuned the original tuning. So I want to now show you the tunings. Muss eventuell der... Ah, okay, alles klar. Gut. Na. Okay. So first we listen to the... First we listen to the original tuning. This is actually just 30 seconds and one cycle of the composition. Na, immer noch nicht? Vielleicht doch da. Nee. Jetzt müsste es gehen. Then we listen to the equal temperament version. The slendro version. The equidistant version. the version with tuned octaves. Pentatonic minor. Pentatonic major. He jazz. And the detuned version of the original tuning. Alles klar, gut. Macht nichts.
I'm sorry, we have to wait for a minute maybe to warm up the beamer again. It was off too long. And next time we want your presentations on wax roll or something like this.
So actually the next step are the results of the roughness measurements and of the online survey. Just waiting for the beamer. So the roughness measurements are actually done over the time. So we have actually a roughness measurement of every stimuli every few milliseconds or every second. And later what was done was like the mean of the roughness measurements were taken. So we have one roughness value per stimuli. And so it's possible to compare the roughness of the pieces. Wow, good. Danke. Okay, here we see actually the measurements of the roughness over the time. We have the different pieces, and we have the roughness value. So if we take the mean, it looks like that. That are the results of the different pieces. Some things were surprising, or maybe are surprising. If we look at the original tuning of the value, we realize that it's, compared to the other pieces, quite high. We also realize that actually the detuned palloc is quite high, which was expected because we have a lot of like instruments that are tuned differently, so we have actually a lot of like clashing of overtones. But it was surprising to see that the original palloc is quite high. So if we think about the theory I talked about in the beginning, we would assume that actually the original tuning has a rather low roughness level compared to the other tunings, because it's supposed to be the result of the combination of the spectrum and the minimal points of auditory roughness. We also realize that actually the slendro tuning, number 3, and the equidistant tuning that are actually really similar have quite a different roughness level. The slendro tuning has a much higher one, even though being also a traditional Javanese tuning. So now we come to the survey. In the survey, we actually ask different gamelan musicians about different questions about the pieces you just heard. Basically, those kind of questions relate to the perception of dissonance. So the following result, I just want to pick out for this presentation one question, and this is, do you think that the gamelan or that the ensemble is out of tune? Yes or no? That's the result. So we also see that the original tuning is actually perceived quite consonant or not out of tune, and which is expected, the detuned palloc version is rated as, from most people, as out of tune. What then was done is actually the number of people, or the amount of people that rated the ensembles out of tune were taken, and we connected them to the results of the roughness measurements. So here we actually have the roughness level of the stimuli on the y-axis, and we have the amount of people that answered the question, is the gamelan or is the ensemble out of tune, with yes, on the x-axis. So we actually see that most pieces, or that actually there seems to be some kind of connection between the amount of people that said the gamelan is out of tune and the roughness level, except for the original tuning, which is on the top, on the left top. So what was done then is, for the testing of a correlation, the original tuning was taken out of the statistics. We discuss later why. So if we take all the other tunings and we do a Pearson correlation coefficient, we realize that there's a high correlation between the positive correlation between the level of roughness of the pieces and the number of participants that said the gamelan is out of tune. Now a discussion. Why could this be, or why is it that this kind of correlation fits for all pieces except the original? For this discussion, I want to bring in some comments of participants, because the participants of the survey were asked to give a free comment on, besides the questions, they could give a free comment on what they think about the survey, about the pieces, how they perceive the pieces. And I want to show you two comments. One participant said, the instruments of B is actually the equal temperament tuning, sound more in tune with each other. Is that right? Yet the tuning of A is the original tuning, is more Javanese and hence nicer to listen to. And maybe even having a few tuning variances between instruments actually makes it nicer to listen to. Another participant said ensemble A, original tuning, sounds more in tune than ensemble B, the equal temperament tuning, in a Javanese way. B sounds closer to a Western tuning. So maybe actually this result means that a few tuning varieties or some kind of tuning varieties between instruments, and therefore maybe a higher auditory roughness level, leads to the impression that a Javanese gamelan sounds as it should sound, because it is not a instrument that is tuned with any kind of device like the other pieces, but it's actually tuned by humans, traditionally tuned without any electronic device, and the instruments actually also change in their tuning, of course. I mean, the gamelan instruments are tuned regularly, good gamelan ensembles, but of course still tunings change. Some instruments are played more than others. So of course it's natural that we have some varieties, while in the pieces that were created using pitch shifting, of course there are no varieties. That might be an idea. Summarizing the results. So actually the mean roughness was taken, the survey results, and a correlation was made between those two results. And actually the original tuning sticks out compared to the others. Now, there are still a lot of things that can be done. As I said in the beginning, there are actually a lot of ensembles also in Indonesia that are not tuned in a traditional way. And maybe